Good, thank you. Thanks so much for inviting me. This is a terrific conference. I have something like 67 slides and I have 30 minutes, which gives me a little less than 30 seconds per slide. You may have seen these maps of the United States starting in 1990 when the most obese states had 10 to 14% of the adults in the overweight category, in the overweight category, obese category. And then going forward from 1990, and I'm trying to go forward and I'm pressing the left click. Do you want to come up? See if you can get it to.
Let me check. Seems it's not going.
Oh, now it's going. Okay, so the most obese states 5 years later, we're at 15 to 19% of adults who are obese. Would you advance? Can you advance? Because it's not responding to me. Can you advance by one slide? Sorry about this. Okay, now that's 2000, now we're up to 20%. 2005, we have a new category. A lot of the U.S. is at 25 to 29%. I think it's working now. Thank you. And a couple states, 3 states are at 30%. And then in 2010, a lot of the central, southern United States has over 30% of the adults in the obese category. So it's, as they say, it's not genetic. Our basic genes haven't changed in 30 years. But what has changed is our environment. And we've had environmental changes, and the one I'm going to focus on today is the built environment and how it has changed. We've had social changes. The social environment has changed. Those two together have changed both food consumption and physical activity. And we've been hearing about food consumption up to this point in the conference. And I'm going to be talking more about physical activity. Those two together, plus other individual factors, have led to the obesity epidemic. So part of it is that we have found ways to have amazingly sedentary lifestyles, and we've created obesogenic environments with escalators going to fitness centers. The term built environment, which I'm focusing on in my talk, refers to elements of the physical environment that are man-made. So I'm talking about buildings, I'm talking about streets, I'm talking about schools, I'm talking about downtown environments, talking about suburban sprawl, as you'll see in just a second. What I was asked to do and what I'll be doing is relating the built environment at 3 different scales to physical activity and ultimately to obesity. And it's not that I am ignoring diabetes. I'm quite aware of the problem. It's just that we do not have a lot of research relating the built environment to diabetes, but we do have now a fair amount, a little bit, that's emerged over the last decade of literature on how the built environment affects obesity. So the focus is on obesity. As an earlier speaker said, obesity is a proxy for diabetes. They move together. So I'll be indirectly talking about diabetes as well. The three scales are macro, which is the scale of the region. It's cities, counties, metropolitan areas. Meso, which is the scale of neighborhoods. And then the micro level is the scale of the street and the buildings along it. So macro scale, what do we know? Well, we in 2002 put out this report through a group called Smart Growth America. And I think I'll probably be referring to smart growth more than once in this presentation, but it's essentially the alternative or opposite of urban sprawl. And I was trying to figure out how to translate urban sprawl into Spanish and didn't make much headway on that, but hopefully the translator will. So we put out Measuring Sprawl and Its Impact in October 2002. We became the first, or actually second, if you include one other attempt, to measure the sprawl in a multi-dimensional way. Sprawl is not just one thing. Sprawl is multiple things. And the multiple things are, as we define sprawl, low density, so where you have, and this is of course in the US context, wouldn't necessarily apply to other countries, but in the US context, low density is sprawl. So low density suburbs are said to sprawl. Segregation of uses, land uses, is also an example of sprawl, where homes are over here and stores are over there and workplaces are up here, separated from one another rather than close together. That's another indicator of sprawl, or a sprawl archetype. A lack of strong centers. What we have a lot of in the United States, and I assume you do here as well, I don't know Mexico well enough to say, but we have a lot of what's called strip commercial development, just miles and miles of retail establishments along roads. The alternative to that is centers of activity, like downtowns, where you can walk around in a center of activity, where you would not walk on a commercial strip. The fourth quality that we measured in our 2002 report was the street network, whether it's a gridded street network with interconnected streets, or whether it's a suburban network, a branching network with a lot of cul-de-sacs and curvy streets. That's a fourth indicator of sprawl, having the curvy streets and the cul-de-sacs. And all four of these relate to the concept of accessibility. A compact environment has land uses accessible to one another. A sprawling environment, they're much less accessible, and you have no alternative to driving your automobile, sometimes long distances. So walking becomes an option in a compact environment, whereas it's not in a sprawling environment. The 2002 report measured sprawl for the major metropolitan areas of the United States. I won't go into a lot about the way we measured sprawl, but we considered a lot of variables and combined them. We also measured sprawl for counties in the U.S. So this is Manhattan, or New York County, as it's also called. It's the most compact county in the United States by far. It's dense, it's got a mix of land uses close together, it has a strong centers like Manhattan itself, and it has a grid of streets, a rectangular grid of streets. And just to show you the contrast, this is Geauga County, which is outside of Cleveland, Ohio, and you can see that it has low density, segregated land uses, poorly connected streets, and no centers whatsoever. So it was the most sprawling county in our 2002 study. So we put, rather than keeping these sprawl indices to ourselves, we published them. And we published them in the hope that other researchers would use them to study the costs of sprawl and the benefits, if there were any. And people did. So we've got all this peer-reviewed literature looking at physical activity and obesity versus sprawl, sprawl versus traffic fatalities, sprawl versus air quality, looking at the effects of sprawl, which are usually negative, not favorable effects, but not always. There's some things that are actually improved by sprawl, but for the most part, most of the impacts that have been measured are negative impacts, where we would like to have fewer traffic fatalities, less residential energy use. So we put out these sprawl measures and made them available, and others have used them. And in 2003, we released this report measuring the health effects of sprawl, focusing specifically on obesity and the chronic diseases that accompany obesity: coronary heart disease, diabetes, hypertension. We published our paper in 2003 in a peer-reviewed journal, and then this happened, and it was unexpected. We knew that there would be some interest in the study, but had no idea that it would be as timely as it was. It's not that it was the world's greatest study. In fact, studies that are being done now of the built environment and obesity are more sophisticated, but it was the first one. And it came out with some factoids that were particularly startling, like if you take the same average American adult and you put him or her in New York City, they will weigh about 6 pounds less than the same person in Geauga County outside of Cleveland. So a 6-pound differential was what we came up with in this original study. And when we came out with that finding, we thought, oh my gosh, what if we're wrong? But since then, there have been a lot of studies that have found the same effects that we did. Sprawl and obesity, this is what we found. For every 50-point increase in the degree of sprawl, there's a 10% increase in the odds of a resident being obese. So 50 points is one standard deviation below the mean sprawl index versus one standard deviation above the mean, a 10% difference in the odds of being obese. A 6% difference in the odds that a resident of a place will have high blood pressure. Now, the interesting thing that we found in this original study was that there wasn't that much more physical activity in the compact places versus sprawling places. In fact, what we found is that in the very compact places, people were getting about 14 minutes of additional leisure walking time per month, which is insignificant. So then we said, well, what's the reason for this? And there are all sorts of possible causal mechanisms, and no one knows for sure why there is this relationship between compactness and obesity. Could it be something as obscure as people in sprawling places spend a lot more time in their cars, and when they're in their cars, as you've noticed looking around, people are constantly eating snack foods in cars. Could it be something that indirect? We don't know, and no one has really come down with definitive research, but we do know that there is a correlation between sprawl and obesity, and it's been shown to be the case in multiple studies. These are 3 other studies that were done using sprawl measures since 2003. So we updated recently. In 2014, we published Measuring Urban Sprawl and Validating Sprawl Measures. We were funded, interestingly enough, even though I'm an urban planner, as you know from my introduction, I'm what's called a city planner, an urban planner. Even though I'm an urban planner, the National Institutes of Health in Bethesda provided the funding, most of the funding for this particular study. And we looked at census counties and urbanized areas and metropolitan areas, all three levels of geography. So here you have again Manhattan, which is the upper left, and this is Brooklyn. These are the most compact counties in the United States, and then at the bottom, Oglethorpe and Grant counties, which are the most sprawling. And what we found basically is confirmed what we had found originally. This is a map of the United States. The darker the color, the more compact the county is. And we published in Health and Place, which was mentioned earlier by in someone's vita. We published this paper in 2014, Relationship Between Urban Sprawl and Physical Activity, Obesity and Morbidity, Update and Refinement. And here's what we found. We found that the relationships between compactness, which is the opposite of sprawl, and these things were all favorable. So the more compact the county, the lower the body mass index, the less likely someone is obese, the less likely someone has high blood pressure, the smaller the chance, the probability of heart disease, and ultimately at the bottom, the one that you can't see but may be most interesting given the emphasis of the conference, the lower the probability of diabetes. So you can see the percentage changes. They're pretty significant. I mean, they're not huge, but a 10% increase in compactness led to a 0.4% decrease in body mass index. Those are the magnitudes of the effects. So that takes care of one scale. I'm going to now go to the second scale, which is the mesoscale. There have been lots of studies, over 200 studies, of neighborhoods and the relationship between neighborhood design and travel choices, how people get around. So, for example, in Fairview Village, which is a village in Portland, Oregon, that area, that county, the people living in the village walk more than 3 times as much as those living in nearby subdivisions. So the fact that it's a village with a village center, with a library, with a post office, with a park, with a daycare, with a health club, causes people to walk more. Southern Village, very similar village arrangement versus subdivisions with curvy roads and no non-residential uses. Walking, as you can see on the bottom here, walking is about 3 times the regional average and higher than neighboring subdivisions. And there have been other studies that have shown that. So we know that people walk more when the D variables, and I'm going to introduce you to the Ds, which are now in my field a pretty big deal, density, diversity, design, distance to transit, and demographics. We define the built environment in terms of these D variables. And we wrote in 2010 a paper looking at travel and the built environment, myself and a guy named Robert Cervero, and we did a meta-study, a meta-analysis, and we found that the effect of all of these Ds were as predicted, that as density goes up, walking goes up. As the diversity of land uses, what's sometimes referred to as mixed land uses, increase, walking goes up, and so on and so forth. Same thing with transit, and you may not think of transit as comparable to walking, but it involves, the reason it's an active mode of transportation is it involves a walk at one or both ends of the transit trip. You have to get to the bus stop or the rail station. And then once you get to your destination, you have to get from the rail station or the bus stop to your office or wherever you're going. So it's, again, fairly large, what are called elasticities, for those of you who are researchers, relating the built environment and the D variables to transit use. Now, we did our work, original work, at the county level. There's a guy named Larry Frank, who's at the University of British Columbia, who's done the same kind of work, and a lot of it at the neighborhood level. And he's gotten results that are remarkably similar to ours, that as land use mix in a neighborhood, that is the mixing of shops and homes and schools and workplaces, as that increases, there's a reduction in the odds of being obese. And these results are statistically significant. So, for example, in his 2006 study, he created a walkability index, and for every 5% increase in walkability, there was a 32% increase in physically active travel, and a 0.23 point decrease in body mass index. So it's not just us who's saying this. Micro scale, and I think I'm still okay time-wise, and you'll tell me if I'm not, I'm sure. Okay, micro scale. The micro scale is the scale, and it's the scale that's not been explored as much as the other two. It's the scale of the individual street. In other words, it's very small scale, or the individual park, or the individual plaza, whatever. So the way we analyzed it is we said there are physical features of a street, such as sidewalk width, street width, traffic volumes, tree canopy, building height, number of people, weather. These are all physical features, and they affect what are referred to by urban designers. That's another field. It's related to my field of urban planning, but it's just a related field. It's distinct. Urban designers talk about urban design qualities or perceptual qualities that they say are important to have active street life, such as imageability. And I'm not going to spend a lot of time on these, but they talk about complexity, that a more complex environment is more interesting, and hence pedestrians are more likely to walk in a complex environment. Human scale, having buildings that aren't huge and streets that aren't wide, that's another thing that urban designers talk about. Transparency, I'll show you that in just a second, that these perceptual qualities have an effect on the overall walking environment, and then they affect walking behavior. And we were the first to do this work. We did it with help from the Robert Wood Johnson Foundation, with funding from them. And I'm going to show you very quickly what we did. So we said there are all these perceptual qualities. This is a street in Annapolis, Maryland, that has all of the qualities that I showed you a second ago. It has transparency, it has imageability, it has complexity, it has visual enclosure to create a kind of like an outdoor room, the building's enclosing space, and so on. This is a shot in San Francisco which has high values of enclosure, transparency, complexity, and coherence, but not of the other things, not of imageability. It's not a particularly memorable street. So we had measured, basically, and this is low values of everything. This is in Rockville, Maryland, outside of Washington, D.C. This was the street we videotaped, which had the lowest values of everything, all of those qualities. We got experts, 10 of them together, and they rated the scenes from our video clips, and we then modeled their ratings in terms of physical features. So they said, for example, that first street I showed you, Annapolis, Maryland, gets a 7 on imageability or a 7 on complexity. And the last street I showed you, Rockville, gets a 2. And so we took their ratings and we modeled their ratings and found that, for example, in the best fit transparency model, the proportion of first floor facade made up of windows was very important. And having active uses on the street were very important. And having a continuous street wall of buildings without breaks between the buildings was very important. So these are the micro scale features we were interested in. So Columbia University in New York took our measures, basically our concepts and our measurement protocols, and applied them to 588 street segments in New York City, and developed their own field manual, different from our field manual, and validated the measures against pedestrian counts. For all of those little red dots you can see are streets that were studied by the group at Columbia. And what we did is we put all our results into a book, Measuring Urban Design. And I'm sorry for this equation, but it's an important one, negative binomial regression model. We found that transparency, the quality I mentioned before of having lots of windows and doors on the street, that's one of the factors that contribute to transparency, was more important than anything else, than density, than diversity, than design. So having transparency, high transparency was important. We found, and that was a novel finding. Human scale was also important. For 1 unit increase in human scale, there's a 11% increase in pedestrian counts. For 1 unit increase in transparency, over a doubling of the number of pedestrians. So you see transparent streetscapes in these two photos. And then ultimately the group in Columbia related it to body mass index. They found there was a relationship between these urban design measures at the street scale and body mass index. So here's my last slide. It says, remember when we used to have to fatten the kids up first? Obesity, as a couple of other speakers have said, obesity starts at a young age. And I'm going to end with a story, and I'm not sure this story is going to work with translation, but I'm going to try it anyway. Oh no, just a second. Okay, so this is from one of my daughters. When my daughter's when she graduated from high school, she left home. We didn't hear from her for quite a while. We finally got this letter from her. It says, "Dear Mom and Dad, I'm sorry I haven't written sooner, but all of my stationery was lost the night the dorm was burned down by demonstrators. I'm out of the hospital now. The doctor says my eyesight may return to normal someday and the skin grafts won't show much. The wonderful boy Bill, who rescued me from the fire, kindly offered to share his apartment with me until I found a new place of my own. You always wanted a grandchild. So you'll be glad to know that you'll be grandparents next month. Love, Alicia. P.S. Please disregard the above exercise in creative writing. There was no fire. I haven't been in the hospital. I'm not pregnant. In fact, I don't even have a boyfriend. But I did get a D in French and an F in math, and I wanted to be sure that you received this news in its proper perspective." Thank you.